Imagine closing your eyes right now. The sounds of the room around you fade away, the feeling of the ground beneath you just vanishes. And when you open your eyes, the world is completely gone. There is no earth, there are no stars.
Just a void.
Exactly. There is only a freezing, dead void, and your isolated brain is just floating in the darkness, momentarily holding on to a fake memory of listening to this very deep dive.
It is a pretty terrifying thought to start the day with.
It really is. Well, welcome to the show, everyone. We are super thrilled to have you here with us. Now, before we unravel the entire nature of reality, I do have a very quick favor to ask you.
Right, the channel update.
Yeah. Because this channel is brand new, please hit that subscribe button and drop a like on this deep dive. Taking 2 seconds to do that is, well, it's the absolute best way to help this channel grow. And it allows us to keep bringing you these intense, mind-expanding explorations into the unknown. So subscribe, like, and let's just dive right into it.
I am very ready for this one.
So today, we are looking at a stack of incredibly dense, borderline, terrifying source material. Specifically, we're digging into a highly provocative 2025 physics paper by David Wolpert, Carlo Rovelli, and Jordan Scharnhorst.
Brilliant physicists, by the way.
Oh, absolutely. And the paper is titled Disentangling Boltzmann Brains, the Time-Symmetry of Memory and the Second Law. So our mission today is to answer the question I basically just posed in that opening scenario. Are your memories, your surroundings, and, your entire life just a momentary random thermal fluctuation in a completely dead universe?
It's basically the ultimate existential question, right? And I mean, looking at the complex Hamiltonian equations and the star charts I've got on the boards behind me today, it's really easy to think of physics as this rigid, comforting set of rules.
Right. We expect the math to tell us that everything is fine, that our reality is solid.
Exactly. We expect the math to prove we exist. But what we're going to explore today is how this seemingly crazy science fiction scenario is actually a deeply serious, totally unresolved problem in statistical mechanics.
Unresolved. That's the scary part.
Yeah, it is a mathematical paradox that actively forces us to question the second law of thermodynamics, the validity of literally every scientific record we have, and, well, the very physical nature of human memory itself.
Okay, so let's start with the existential threat at the center of this paper. The Boltzmann brain. We really need to define exactly what this is, and more importantly, the physical laws that suggest it might actually be a real thing.
Because it's not just a thought experiment.
Right. This isn't just philosophers sitting in a room playing what if. The actual mathematics of statistical mechanics points directly to this.
It does. It stems directly from the foundational rules of thermodynamics. To understand the mechanism here, you have to imagine a universe that has reached a state of maximum entropy.
Okay.
This is what physicists call thermal equilibrium. Essentially, all the stars have burned out, all the black holes have completely evaporated, and what's left is just this vast dead soup of microscopic particles.
Where the temperature is uniform and literally nothing interesting is happening anywhere.
Right. But statistical mechanics tells us that if this dead system remains in that state for an arbitrarily long span of time, and we are talking infinite time here, random microscopic fluctuations will still occur.
Particles will just randomly bump together.
Exactly. They still have tiny bits of energy, so they bump.
So if you wait long enough, those random bumps are going to eventually create something. It makes me think of taking 1 billion jigsaw puzzle pieces, throwing them into a massive commercial dryer, and just letting it spin.
That's a good visual.
Right. And if you leave it spinning for eternity, eventually, purely by accident, you'll open the door and find the pieces have randomly interlocked to form a perfect image of the Mona Lisa.
That is actually a highly accurate way to visualize phase space and probability. Because given infinite time, literally every possible physical arrangement of particles will eventually happen just by pure chance.
Even incredible complex things.
Yes. And one of those arrangements is a fully functioning, biologically accurate human brain, complete with the exact neural pathways encoding your memories of waking up this morning, your perceptions of sitting in your room, and your thoughts right now.
All completely unattached to any real external physical world.
None of it.
The puzzle just happened to form my brain for a split second.
With exactly the memories and sensory inputs you're experiencing in this exact moment, but they would be entirely false. It's just a fleeting physical illusion created by a random thermal fluctuation. And statistically, it is destined to just dissolve back into the chaotic soup of particles a fraction of a second later.
Okay, I have to push back on this, though. Because I look around and our current universe clearly has low entropy.
It does.
We see stars actively burning, complex biological life evolving, galaxies holding together. So doesn't the second law of thermodynamics, the rule that entropy always increases over time, moving from order to disorder, doesn't that prove we're part of a continuously evolving universe?
You would think so, right?
Yeah. How can we be a random, isolated blip when we clearly see an ordered universe actively moving toward disorder?
Well, you are touching on the exact trap that physicists fall into. The paper formalizes something called the entropy conjecture, which highlights why the second law actually makes the Boltzmann brain problem way worse, not better.
Wait, worse. How does it make it worse?
To understand why, we have to look at the microscopic laws of physics, like Newtonian mechanics. Those foundational equations are perfectly symmetric under time inversion.
Meaning what, exactly?
The math operates exactly the same whether time is moving forward or backward.
Oh, I see. Meaning on a microscopic level, two particles colliding look exactly the same, whether you play the video forward or in reverse.
Right. The fundamental math doesn't care which way the clock ticks. It doesn't care at all. So, if the underlying laws are time-symmetric, but we observe that our universe has low entropy right now, we have to treat this mathematically as a stochastic process.
A completely random process based purely on probability.
Exactly. And probability dictates something highly counterintuitive here. If you find a random system in a highly ordered low entropy state, the overwhelmingly most likely scenario is that entropy should increase going forward in time, which matches our daily experience, of course.
Sure, things decay, things get messy.
But the math says it should also increase going backward in time.
Wait, increase going backward. I need you to break that down. If I go backward in time, my intuition says things should get more ordered, not less.
Let's apply your puzzle analogy again. You open the dryer and see the Mona Lisa. What is the most statistically probable history of that puzzle in a totally random system?
Okay.
Is it more likely that 10 minutes ago it was an even more perfectly organized puzzle, slowly evolving into the Mona Lisa? Or is it infinitely more likely that 10 minutes ago it was total chaos, it randomly fluctuated down into the Mona Lisa for the brief second you open the door, and a second later it'll just be chaos again?
Oh, wow. Yeah. Because there are astronomically more ways for the pieces to be disordered than ordered.
Millions and billions of ways.
So if I find it in a rare ordered state right now, the states immediately preceding it and immediately following it are almost certainly totally disordered.
You've nailed the exact mechanism. Statistically, if we are in a low entropy state right now, it is infinitely more probable that we are simply sitting at the very bottom of a temporary entropy dip, a Boltzmann brain fluctuation.
Rather than a real universe.
Right. It's way more likely than the idea that the entire universe has been smoothly evolving from an even lower entropy state for billions of years.
That is genuinely unsettling. I mean, the math actively suggests it's more likely I'm a momentary blip than a human with a real cosmic history. But I know a lot of physicists absolutely reject this idea.
But they hate it.
The paper spends a significant amount of time detailing how scientists try to fight this theory and the specific logical traps they inevitably fall into.
They fight it because if the Boltzmann brain hypothesis is true, it literally destroys the foundation of empirical science. If you are a Boltzmann brain, your memories of the past are fake.
Which means all of our data is fake.
Crucially, yes. That includes your memories of every scientific experiment ever conducted. The standard scientific argument against the Boltzmann brain relies heavily on our knowledge of physical laws. Physicists will say, well, we know the second law of thermodynamics is true, and we know our universe has a deep history because we have recorded data from past experiments.
But if the theory is correct, those records are fake. It's like a computer with a corrupted hard drive trying to run a diagnostic test on itself to prove it's not corrupted.
That is a brilliant way to frame it.
The diagnostic software itself is compromised. You can't trust the output of the very system you are trying to verify.
Exactly. Philosophers and physicists refer to this paradox as cognitive instability or unstable reasoning. The counter-argument relies on the second law to prove that our memories and scientific records are reliable. But if the Boltzmann brain hypothesis is true, the second law was radically violated in our immediate past to create the brain out of nowhere, meaning those scientific records are just random thermal noise. You cannot use a piece of evidence to prove a theory if that exact theory simultaneously proves your evidence is an illusion.
So does this unstable reasoning actually solve the problem then? Like, if the logic of the Boltzmann brain collapses on itself, doesn't that mean we can just throw the theory out? It feels like a paradox that kind of proves itself wrong.
You'd hope so. But the authors of the paper are very mathematically rigorous about this. They use formal Bayesian logic to show that unstable reasoning doesn't disprove the Boltzmann brain at all.
It doesn't.
No, it simply proves that the specific counterargument we are using contradicts itself.
Mm.
You can't use compromised memory to disprove a theory that says your memory is compromised.
Oh, man. So it just invalidates our argument, not the actual physics.
Exactly. The theory of the Boltzmann brain remains a perfectly valid mathematical outcome of statistical mechanics.
Yeah.
It's our human attempt to argue against it using our flawed perception of the past that breaks down completely.
So we're just stuck in an epistemic trap. We can't prove it, and we can't disprove it because our tools for proving things are literally compromised.
Pretty much.
But the paper offers a fascinating variant of the fluctuation theory that completely bypasses this corrupted hard drive problem. They call it the 1000 CE hypothesis.
They do, and it's a really profound thought experiment. What if the random thermal fluctuation didn't just create a single brain today? What if the universe fluctuated down to its minimum lowest entropy state in the year 1000 CE, creating the entire Earth, the sun, and the stars exactly as they existed in that specific year?
Okay, let me make sure I understand the mechanics of this. The universe is a dead soup of particles. Then purely by chance, it randomly fluctuates into a massive, highly ordered state that exactly mirrors the Middle Ages. And from that precise moment forward, the fluctuation stops, and the standard laws of thermodynamics just take over again.
The standard laws resume. Entropy begins to naturally increase exactly as we expect it to. From 1000 CE to today, people live, die, write books, invent telescopes, and run particle accelerators.
Meaning our modern scientific records, all the data we use to prove the laws of physics, are actually real. They were formed by real thermodynamic processes over the last 1,000 years, not by a random brain fluctuation 5 seconds ago.
You've got it. In this scenario, the second law of thermodynamics has been working perfectly normally for the last 10 centuries. Therefore, your memories of reading physics textbooks and humanity's collective data from the Renaissance to the modern day are perfectly valid. They were real physical records of a real physical past.
You know, this actually reminds me of something interesting outside of physics. When we talk about the universe just popping into existence with a fully formed, completely fake history baked in, it sounds a lot like some theological arguments.
Oh, like creationism.
Yeah, exactly. Look at the Bible as an example, and its claim that the world was created only thousands of years ago, like roughly 6,000 years ago. Obviously, we're not taking a stance on religion here, we're just looking at the source material. But could you argue that this religious statement might actually be mechanically correct in this framework?
That is a fascinating parallel. And from a pure physics standpoint, yes, you could theoretically model that claim as a massive Boltzmann fluctuation.
Really? Just plug it into the math.
Yeah, if the universe fluctuated down to a low entropy state a few thousand years ago, perfectly arranging the Earth, the starlight already in transit, and fossils in the ground, then the statement, the universe started thousands of years ago, would technically be physically correct in this model.
But everything before that would be an illusion.
Right. It would mean that the scientific claim that dinosaurs actually walked the Earth millions of years ago would be wrong. The fossils would just be fake records baked into that initial low entropy state.
That is wild. So the physics mechanics actually allow for a scenario that looks exactly like that theological claim.
Statistically, yes. Though obviously the math doesn't care about theology. It just shows that a universe with the appearance of a deep history can absolutely be created in an instant. But going back to the paper-specific example, picking the year 1000 CE feels entirely arbitrary.
Yeah, why would the universe just happen to bottom out exactly 1,000 years ago?
It is entirely arbitrary, and the authors are using that arbitrariness to make a devastating point. By picking a random date in the past, they mathematically prove you can have a universe that's fundamentally a giant random fluctuation, a Boltzmann universe, but where our modern scientific data is still perfectly reliable.
Oh, I see. It beautifully sidesteps the cognitive instability argument. Because the science is valid, we don't have the corrupted hard drive problem anymore.
Exactly. If the fluctuation happened in 1000 CE, we can absolutely trust our physics experiments today. But the existential horror remains, because everything before the year 1000 CE, like the Roman Empire, the dinosaurs we just mentioned, the formation of the Earth, never actually happened.
They're just fake historical records.
Simply baked into the low entropy state that fluctuated into existence. It proves that the Boltzmann problem is much, much harder to kill than physicists want to admit, because you can always construct models that preserve our scientific data while still being random thermal blips.
Wow. Okay. So if anchoring the lowest entropy point at 1000 CE is just arbitrary, let's look at what happens if we anchor it where modern cosmologists actually prefer to anchor it. They anchor it at the Big Bang.
They do.
Standard science says the universe started with incredibly low entropy 13.8 billion years ago, and it's just been smoothly expanding and decaying ever since.
Pinning that lowest entropy state to the Big Bang is known in physics as the past hypothesis. It is the standard shield physicists use to defend against Boltzmann brains.
It's their safety net.
Exactly. They assume the universe simply started with extremely low entropy at the Big Bang, and the second law has been driving it upward ever since. But the paper identifies a massive fundamental flaw in the mathematics of how scientists actually calculate this. And it all comes down to Bayesian probability.
Now, Bayesian probability is all about updating our beliefs based on evidence, right?
It's deeper than just updating beliefs. In formal Bayesian probability, there is a strict mathematical requirement called the construction rule.
The construction rule, okay.
The construction rule states that when you build a probabilistic model, you must condition your math on all the reliable data you have available. You cannot cherry pick which data points to include.
Right, you have to use everything you know.
Exactly. Now, cosmologists have observational data, like the cosmic microwave background, suggesting low entropy at the Big Bang. So they plug that data point into the math.
But we also have indisputable data that entropy is relatively low right now. I mean, in fact, compared to total thermal equilibrium, the room I am sitting in is a miracle of low entropy.
Yes, it is.
And frankly, I am much more certain of the data sitting right in front of me today than I am of data from 13.8 billion years ago.
Which means, to strictly follow the Bayesian construction rule, physicists must mathematically anchor their stochastic process at both points in time. They have to fix the math at the low entropy of the Big Bang and fix it at the relatively low entropy of the present moment.
It makes me think of pinning a heavy jump rope to a wall. You pin one end at the Big Bang and you pin the other end right here at the present day. What does the math do in the middle?
The jump rope sags. In a stochastic process, the natural tendency of a random system is always to maximize entropy. It wants to be in a state of chaotic equilibrium.
It wants to be messy.
Always. So if you force the math to be low entropy at the Big Bang, and you force it to be low entropy today, the probability curve naturally bulges upward into high entropy in the vast span of time between those 2 points.
Wait, if the rope sags, if the entropy bulges upward between the Big Bang and today, that changes everything about how we view our recent past.
Let's follow the curve. Start at the present moment, where entropy is low, and trace the math backward in time toward the middle of that jump rope. What happens to the expected entropy?
It goes up. The math says that as we look backward into our recent past, the expected entropy actually increases before it eventually goes back down to meet the Big Bang.
And that is the paper's most shocking mathematical conclusion. By strictly following Bayesian rules and conditioning on both points in time, the expected entropy in our recent past should be higher than it is today.
But that completely violates the second law of thermodynamics. We know entropy was lower yesterday than it is today. My coffee was hotter yesterday.
Yes.
It implies that to make the standard cosmological model work, physicists are basically ignoring the data of the present moment because it ruins their clean, smooth mathematical curve coming from the Big Bang.
You're exactly right. They are implicitly violating the construction rules of Bayesian reasoning. To save the past hypothesis from the exact same mathematical traps that create the Boltzmann brain, they have to abandon rigorous statistical probability. They have to cherry-pick their boundaries.
Which is pretty bad science. This brings us to a major crisis of reality, honestly, because all of this mathematical truth, the idea that the past might be an illusion, or that strictly following the math breaks the second law, it feels so incredibly wrong to us on a human level.
It's deeply uncomfortable.
Why does our physical intuition fight this mathematics so hard?
It comes down to the physical nature of human memory itself. We tend to think of memory as some abstract, ethereal concept, like video playing in our minds. But memory is a physical system.
Right.
The paper categorizes it as type 3 memory, a macroscopic physical record. Think of a crater on the moon.
Okay, right. Those aren't just ideas. They are localized areas of physical change. Creating a crater requires a massive transfer of kinetic energy into heat, permanently altering the physical structure of the moon through thermodynamic dissipation.
Which means they are entirely reliant on the macroscopic arrow of time. A physical system relies entirely on the second law to distinguish the past from the future. Because macroscopic entropy increases, energy dissipates, leaving a permanent scar.
We can look at a crater and say with absolute confidence a meteor hit this in the past.
Yes. And your brain forms memories through a very similar process of chemical and thermodynamic dissipation.
So my brain is physically hardwired by thermodynamics to trust retrodiction, looking backward at records over prediction.
Yes, exactly.
I am much more confident about the physical record of what I ate for breakfast than I am about predicting what I will eat for dinner tomorrow. But the fundamental microscopic laws of the universe say the math works exactly the same in both directions. Are we really saying it's statistically more likely that my physical memory of breakfast is just a random arrangement of neurons rather than a real event?
As crazy as it sounds, yes.
Yeah.
Human intuition almost always fails us when dealing with fundamental physics. Think about quantum mechanics. It violates every intuitive sense we have about solid matter and location, but the math is undeniable.
That's true.
The same is absolutely true for statistical mechanics. The math shows it requires an extraordinary, unbelievable amount of fine-tuning for the entire universe to smoothly evolve from the incredibly low entropy state of the Big Bang to where we are now. It is a massive statistical miracle.
It's basically impossible odds.
Right. Conversely, statistically, it is infinitely more probable that the physical particles making up the neurons in your brain just randomly fluctuated into the exact physical arrangement of remembering breakfast.
Mind-blowing.
Your deep intuitive belief that your memories accurately reflect the past is just an evolutionary biological bias.
Yeah.
It is not a physical certainty guaranteed by the microscopic laws of the universe.
So, to sort of summarize the terrifying place we have landed in this deep dive, physics simply cannot disprove the Boltzmann brain without forcing arbitrary assumptions into the math. You either have to cherry-pick your data, ignoring the present to favor the Big Bang, or you have to rely on unstable reasoning, where you use compromised memories to prove the physical laws that tell you your memories are compromised.
It's a closed loop of logic.
The second law of thermodynamics, our human memories, and the very history of the universe are all tangled incredibly tightly together, and pulling on any single thread just unravels the entire fabric of reality.
We're ultimately left with a universe where our absolute confidence in the past is built on mathematical foundations that, when examined rigorously, suggest that very past might not exist at all.
Which leaves us with a final, provocative thought for you to mull over today. Think about your own mind right now. You've been listening to us explore this complex physics for the last 20 minutes or so. But if your brain, along with all its intricate memories of this conversation, its sensory perceptions of your room, and its capacity for logical reasoning, really did just pop into existence from the freezing thermal void a single millisecond ago, how would your experience of listening to this very deep dive feel any different than it does right now?
It wouldn't.
Thanks for joining us. We'll see you next time.